Hello students, welcome to the first lecture of Unit 2 as System of Variable Composition. We begin this unit by revising some basic concepts of molarity, molality and mole fraction, and finally delve into the first topic, that is the partial molar quantities. The thermodynamic properties, be it internal energy, enthalpy, free energy or entropy, they are all function of pressure, volume and temperature for a constant composition. When the composition is not constant, then these thermodynamic properties depend on four functions, that is pressure, volume, temperature and the number of moles. U, H, G and S, that is the internal energy U, the enthalpy H, the Gibbs free energy G and the entropy S are extensive properties. Now what are extensive and intensive properties? Extensive properties are those that depend upon the mass and chemical composition, or we can say the number of moles of the system. However, the intensive properties do not depend on such factor. For a closed system, any change in the thermodynamic properties such as internal energy, enthalpy, free energy or entropy is due to the change in the state of the system, because since the system we are discussing is a closed system, the change cannot be brought about by addition or removal of matter. However, for open system, such change may depend upon any one of the pressure, volume, temperature or the composition of the system. Here is the basic definition of weight percent, molarity, molality, normality, mole fraction and mole percent. This you have already gone through in your higher secondary classes. What is molarity? It is the number of mole of solute per liter of the solution. What is molality? It is the number of mole of solute per 1000 gram or per kg of solvent. Similarly, you have gone about normality. It is the equivalence of solute per liter of the solution, and mole fraction is the number of mole of solute divided by the total number of mole in the solution. Here is a question for you to try out. Suppose a solution of sulfuric acid is prepared by addition of 32.5 into 10 to the power minus 3 kg of acid to this much amount of water, and the density of the resulting solution is given. Now you have to calculate 5 things. First one is the concentration is weight percent. What is the molality of the solution, the molarity, the normality and the mole fraction of that solution. How will you solve this question? First, you have to determine the weight percent. The formula for weight percent is 100 into W2 by W1 plus W2. What is the molality? You have to just put in the formula and the molarity. Finally, this is how you solve the whole question. Now let us discuss about the partial molar quantities. For a system of variable composition, any thermodynamic property X depends upon two of the three variables, that is pressure, volume and temperature. Of these three variables, the thermodynamic property X depends upon any two and also on the number of moles of the system. The contribution that any component of a mixture makes to the total property of the sample. So the partial molar quantity determine the contribution that any component of a mixture is making to the total property of the sample. Mathematically it is here X equal to F, that is the function of temperature, pressure, N1, N2 up till Ni, where N1, N2 up till Ni represent what? They represent a number of mole of the respective constituent in a total volume V of the system. Suppose an infinitesimal change in X is observed, and it will be due to the infinitesimal changes in temperature, pressure and other variables like the number of moles Ni. This is represented as, can be seen here, dx is equal to del x by del p at constant temperature N1, N2 up till Ni into dp. Addition to it is the del x by del t at constant pressure N1, N2 up till Ni into dt plus del x by del Ni at constant temperature, pressure. Here you see, here we have taken N1 to be variable, and the constants are from N2 up till Ni, and here as you can see it is dN1. Added to it is del x by del N2 at constant temperature, pressure, N1, N2 is variable, so N3 up till Ni, here it is the dN2. Similarly, the last term will be del x by del Ni at constant temperature, pressure, Nj dNi, where I is not equal to J. When the temperature and pressure is constant, this term changes to this, where only the constant temperature and pressure terms are included, and this terms becomes 0. And these terms can be, since dp and dt are 0 because they are constant, so the whole term, this whole term becomes 0, and we only have the rest of the terms where temperature and pressure constant does not affect this value. Now each partial derivative, this partial derivative can be written as del x by del N1 at constant temperature, pressure, N2 up till Ni equal to x bar 1. Similarly here it is written as x bar 2 until we get x bar I, where x1 is the partial molar property of the first component and xi bar is the partial molar property of the ith component. Okay, so this is how we make the derivation. These are called the partial molar quantities. The partial molar quantities are indicated by putting a bar over the ith symbol. Whichever quantity you are taken to be a partial molar quantity, you have to put a bar over it, and it becomes equal to the property per mole. Okay, since it is division by the number of moles, so it becomes a property of per mole. So for infinitesimal change in Gibbs free energy G at constant temperature and pressure, how we can write? We can write dG at constant temperature, pressure, G1 bar dN1 plus G2 bar dN2, just similar to what we have found in the previous slide. So the partial molar property of the ith constituent of a mixture is the increase in this property of system resulting from addition at constant temperature and pressure of 1 mole of I to such a large quantity of the system that the composition of the system remains virtually unchanged. That means, what is the partial molar quantity? For the ith constituent of any mixture, it is the increase in the property. Increase in the property of the system due to the addition of 1 mole of I to a large quantity. We are adding just 1 mole to a large quantity, that the composition of the system also remains virtually unchanged. So the quantity of the system is so large that addition of 1 mole does not change the composition of the system, but the condition is at constant temperature and pressure. Please go through the slide once again to understand it clearly. With this, we end today's lecture, but we will continue this topic in our next lecture. If you have any doubts, please post your comments in Google Classroom, or you can also WhatsApp me or email me. Thank you for your attention today.